Hi guys, today we are going to look at something called arithmetic series. Series are different from sequences, and we're going to jump right in and look at what is that difference. So a series is the sum of the terms of a sequence. So a sequence or series both can be either infinite or finite. I don't know why those two words are pronounced differently, but here we are. So a sequence, this is what we've been looking at up till now. Notice a finite sequence comes to an end. There's no continuation. It's just 3, 6, 9, 12, 15. An infinite sequence continues on. The ... means it goes on and on forever until Jesus comes back. And then we've got the series, which is taking the numbers of the sequence and putting a plus in the middle. And so finite means it stops after 15. Infinite means it goes on forever and ever. So use the finite sequence below. You see that's a sequence because they're separated by commas, and that it ends, there's no ... to write the related series, then evaluate the series. So essentially, all I'm going to do is take each of these numbers, write them again, and put a plus in the middle. Voila! It's going to look like this. So then, we've written it as a sequence. We did that. And then we need to evaluate the series. So what that means is plug all these in, or add them all together, however you want to call it. And if we added all of those up, we would get 16.5. This is the series evaluated. So there's an easier way to do this. There's actually a formula. So we say the sum, S sub n, S stands for sum, and n means the number of terms in the sequence of this series is given by this right here. We've got the sum of however many terms is equal to the number of terms divided by 2 times the first term and the last term. So you see here, a sub 1 just means what is the first term, a sub n means what is the nth term, and n is the number of terms. All right, so we're going to use that formula quite a bit today. Find the value of the series if there are 7 terms. So I'm going to write down our formula real quick. We had S sub n equals n over 2 times a sub 1 plus a sub n. Now the first thing I'm going to do, and what you're going to be expected to do on your homework, is to identify the key pieces of this. I need to know what n is. N is how many terms. It tells me that there are 7, so n equals 7. My first term is 5. It's just the first one in the series. And a sub n means a sub 7, or the last term, which in this case they told me is 29. So I'm going to list all 3 parts, and then I'm going to write it out in formula. So S sub 7 equals 7 over 2 times 5 plus 29. This would give us 7 over 2 times, 34. So really we would have 119. So what this is saying is that if I wrote out all 5 of these terms plus the couple that are missing in here and added them together, I would get 119 as my answer. All right, so we can also use summation notation to write a series. This is an example of summation notation. We've got some important things here. This is the lower limit. What is the smallest value of n? Are we starting with the first term? We'll even look at some examples where we start with the second or third term. There are cases in the real world where you would do that, but we can talk about that at a later time. You've got the upper limit. This is the largest value of n. So what this series is saying is we're going to evaluate the first, second, and third terms. The first term, third term, and any term in between. We never have like 1.5 for n because we can't have a 1.5 term. It has to be the first, the second, the third, etc. And then this over here is the explicit formula that we're using. So what this would mean is substitute in n equals 1, substitute in n equals 2, and n equals 3 to this formula, and this sigma sign means to add them together. So write the series below. Let's just practice writing in summation notation. So I'm going to draw my sigma, which it's kind of fun actually. And unless they tell me otherwise, I'm going to assume that this is the first term. So I'm going to say n equals 1 because I start with the first term. And then my upper limit, or the maximum term that I find, is 6. It tells me right here n equals 6. So then I still have to fill in, what is this formula over here? So this is going back a couple of days, and we have to remember how to write an arithmetic sequence formula. So to do that, what we're going to do is identify our common difference, which is, it's just adding 1 every time. We have to identify our first term, and we're going to say that the first term is 1, and we would get a sub n equals a sub 1 plus n minus 1 times 1. Now, before I told you if you wanted to write your formula like this, that would be fine. But for summation notation, we have to simplify it. So I hope a lot of you were practicing already, but make sure that you continue to do so. So if I distribute this 1 to everything, I get 1 plus n minus 1. Well, those 1s are going to cancel out, and so really I just get a sub n equals n. So my formula is going to be n, and I'm going to put it in parentheses. Just so it's kind of just common practice to put it in parentheses so we know that we're saying that this is all the formula. This from 5n to the plus 1, all of that is part of the formula. There's nothing that is outside of it. All right, so let's try another one. Sigma, and again, start with n equals 1. And this time there are 9 terms, so I'm going to go to 9. So my there we go. Sorry, guys. Okay, so our common difference is 6. We're adding 6. Oh, no, sorry. 5. We're adding 5 every time. And then our first term is 3. Okay, so I've got a sub n equals the first term plus n minus 1 times 5. I'm going to distribute that 5 to everything, and I get 3 plus 5n minus 5. I'm going to combine those together, and I'm going to get 5n minus 2. There we go. So this would be your final answer. All right, find the number of terms, the first term and the last term, then evaluate the series. So my first term, or my number of terms, let's start with that, number of terms. It looks like I start at 1 and go to 10. So if I count how many terms that is, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 terms. My first term is going to be what happens when I take this lower limit and I substitute it in. So I plug in 1 for n. And when I do that, I get negative 2. My last term is going to be taking this last number, or the upper boundary, and plugging it in for n. So I'd have 10 minus 3, which is 7. So there's the first part. I said number of terms, first term, last term, then evaluate. So now these are all the pieces that I need to keep using our formula. So we're going to say s sub 10, because there's 10 terms. It's going to be 10 over 2 times 2 plus 7. Well, 2 plus 7 gives me 9. 10 divided by 2 is 5. And so I'm going to have equals 5 times 9, which is 45. So this would be the evaluation of the formula, of the series, excuse me. Let's look at one more. We've got to find the number of terms. This time, notice we start at 2. So if I think about this, I've got terms 2, 3, 4, and 5. So my number of terms is going to be 4. My first term is going to be what I get when I plug in this first term for n. So when I do that, I get 2 squared, which is 4. And then I need to plug in my last term for n, and I'd get 5 squared, which is 25. Now I've got s sub 4 because there's 4 terms. Again, it's not just whatever the top number is. Equals 4 over 2 times 4 plus 25. That would give me 2 times 29, and that would give us 58. Voila! And that's how we are going to do geometric series. Homework is posted in Google Classroom. Take a look. Let me know if you have questions.